Hello all and welcome back. So in this module, we are going to start with a new data structure, which is queue. So till now, we have learned about some inbuilt data structures and have also implemented few data structures such as linked list and stacks. Now let us begin with queue and try to understand the same. We will be making sure that we understand each and everything, try to implement the same in different ways, and then solve the question so as to solidify our learning. So let's get started. Now, the best overall definition of queue is that queue is a queue. Well, it may seem a little bit easy or a lot complex, but that's actually the easiest way of defining a queue. Since our life, we have been making queues, right? So we have made a queue in front of any fast food chain, maybe McDonald's or something. We have, of course, been to some event where we have made a queue. Then we also have made a queue at bank. Okay. So whenever things are one after the another in a sequence. Okay. So it is also a linear data structure. Linear data structure that we say is a queue. So just to draw it out, going to be a lot easy. So this is one person. Okay. Let's say we have multiple such person and they are waiting in front of some food chain. So to understand queue, we will just see that what is the behavior which we have seen in our real life in queues. Okay. Let's say this is some food counter, everyone. Few things which we know from our experience is that this person must have come first, right? So I'm not taking the case where you can enter from middle or something. No, you have to make sure that you are following the order of queue. So if a new person comes in tomorrow, he will be coming in towards the end. Okay. So this person must have come first, and because of that, he will get food first. In a very similar way, this person who just came is last and will be served last. Okay. So pretty straightforward stuff. Just the way we have queues, something which we have seen since our life. Just those are that is the major idea behind the queue data structure. So to just delve a little deep, what we have to see, everyone, it's actually a structure like this. Okay. Where I have an out, which is from here, and an in, which can be from here. So you are entering into one side and you are exiting from one side, right? That is actually the idea behind queue. Now, as I said, we have seen queue at a bank, we have seen queue at a movie theater, at some food chain. All of us has actually, in a way, experienced the same. So whenever we have a use case where we want things to get overall executed in the order they came in, that is where we want to use queue. Okay. So let us understand a little bit more, everyone. Let us see some examples. So this is a normal queue of people, like they might be waiting for something. They will be, let's say, or outside some bank or something, maybe outside some shop, or maybe outside the Comic Con, right? So they are maintaining a queue. Now this person overall will be the first one, and this person will be the last one. Okay, great. Another very good example of queue is around the toll tax. So we have these things, right? We have these cars. Let's say there is a toll. Okay, there is a toll plaza, right? Now the car which comes in first will of course be the one which goes out first, right? So first in, first out. So as compared to our stack, it is totally opposite. So the thing which is coming in first is the one which goes out first. So we also say that it's a FIFO kind of a data structure. Similarly, we can also say at LILO, last in, last out. Okay. Though we will majorly be using FIFO only, everyone. So what I can write is that Q is a FIFO data structure. Okay. First in, first out. Great. So let us move forward, everyone, and see. First one to come in is the first one to go out, assuming that no one is coming in between, and there is just one exit and one entry, right? So now let us see some more real world examples, everyone. So more real life examples, which will help you to understand that why exactly do we need them, right? The very first one, along with all those which we have seen, is your printer job as well. So in a printer, when you use a printer, right, the sequence in which you send your papers to get printed, the documents to get printed, that is what is followed, right? You can see in the settings as well that what is the overall order in which your jobs or your PDFs or any document which you are sending will be printed. And you will also see maybe in some printers that printer queue or queue waiting up, these kind of words pops up, right? The next one can be the customer support. All of us have called at various customer support where they say that you are the fourth one in the queue, then you are the third one in the queue, so they ask us to wait. So these are all the examples along with the examples which we have seen, right? We have already seen the examples of line at a bank or something, as well as the toll booth. Okay, then next one can be elevator request. So the way you request for the elevator, that is what is served first, right? In many places it happens that the order in which you give the request to an elevator, that is how it gets overall executed. And one more can be task scheduling. So the way we schedule task, okay, that also follows a queue that hey, first do this, then do this. So this is overall the basic real life examples of your queue. Now let me give you some industry example as well, because tomorrow someone can ask you that where queues can be used in industry. So talking to about industry based examples, we have here something known as job scheduling. So one second, job scheduling, very similar to the task scheduling, just that it's a technical terms where multiple jobs, if a computer or a system has to execute, they will be executed in order, right? Then network traffic is something where we also use queue, network traffic. Okay, where let's say if the traffic is coming, the overall request gets I would say answered in the way they were basically sent. Last one can be a messaging service. So Kafka, RabbitMQ, these are some services, right? So the basic idea behind them is queue only. Okay, so these are all very complex services by themselves, but the basic idea behind them is queue only. Okay, so RabbitMQ, Amazon SQS is also there. Then Kafka is there. And of course, then there are lots of other use cases as well, everyone. So we can use queue to make sure that any particular task, if let's say in our laptop, anything which we want to execute in order, okay, that is how they are executed. Then even let's say if the code which you are writing, maybe some compiler is actually storing them in a queue that okay, what exactly has to be executed after what, right? So which line has to be executed after which line. Then a lot of use of queues lies in breadth first search. So it's an algorithm, BFS, very common. We are not going to study it right now, we'll be studying that in future, but there also we will be using queues. So that's why as well we should have an idea on what queue actually are. Okay, so I hope that is clear, everyone. You got the very basic idea behind queue. Now I have tried to keep it simple, but just made sure that I'm giving you lots of examples so that you never get confused. And in any interview, or if you have to explain anyone, you should never be having any dearth of examples. Always remember these industry examples as well, because they can be very well asked. And let me write the BFS algo as well, because that is also a lot good example of our queues, BFS. Okay. Great all. So I hope that is clear. Now let's meet in the next video where we will continue our discussion on queues. Thank you.